we rely on a wide range of machines or systems, but the truth is that every system eventually breaks down unless it is being maintained. The ability to use AI machine learning models and deep learning models has made it much easier to solve these problems. Energy system failure led to a power outage. However, to first install AI-based predictive maintenance, it is important to figure out this type of data involved in the process. Acquire and analyze those data can help us answer different questions about pen fuel cell system. If the system behaves abnormally, if there's a fault on the system, what causes the fault, when the system is going to fail, remaining useful life of the system, fuel cell degradation. In this video, we'll talk about the workflow for developing INNN predictive maintenance model for pen fuel cell system using MATLAB with 1,000 hours of training dataset collected from Togi University at Shanghai. In this image, this is the raw long-term dynamic durability test for the pen fuel cells. We have built a simple ANN artificial neural network with MATLAB to train it on supervised model. By selecting 16 input features, which will help us predict the output voltage of the pen fuel cell.
In this part of the video, we will demonstrate how we use the training data set with MATLAB to build our artificial neural network. The first thing we do is to use the read matrix command to import our data set. Our data set is composed of 17 columns. We use the first 16 for input feature to build our training model, and the last column, which is the voltage, the 17 column, we use it for the predicted voltage in our model. The second thing we do is to do a visualization using an histogram to plot the data. But in case the data is screwed, we normalize all the input feature from our data sets. After that, we plot the normalized output y as a function of one of the normalized input. And we start to train the artificial neural network, define the function fitnet to train the network. We create a heating layer which is composed of 10 neurons. And we take a partial of the data for a training, another part of the data for validation. So we set up the training ratio as 70% of the data and the validation ratio as 30% of the data. And furthermore, and finally, we use the train command to train our network. Using the train command to train our network, we got a graphical representation of our training network. So, like I said, we have like 16 input feature, and there's like 16 input feature. And the heating layer, we got like 10 neurons with the bias and the weight. And as the output, we only got one output, which is the predicted voltage that we're looking for in our training network. And for performance of the artificial neural network, we use the root mean square error of the training data set and the root mean square error of the validation data set. And these two is similar, that is a proof that our network is not overfitted. For answer, we got 0.010 for the training set and 0.0017 for the validation set. So our next plan is to use a network more complicated. Other than one heating layer with 10 neurons, we could use 16 neurons to get the best result and performance of our network. That is our plan for the next video.